Okay, audio should be turned on now. So I'm trying to create a Ethereum contract here. The contract itself has been created. Right here, I'm trying to retrieve all the contracts that I've created so far, and then try to create a class of the contract that I've then created, and then I'm trying to get an instance from it right here. The goal of this component is to eventually show the deployed instance of a contract that's been sent out to the Ethereum network. So running into some issues with deployed right here. That's what I'm trying to troubleshoot right now. I'm going to move chat over here. Yeah, if you have any questions, just let me know, because I really streaming right now, trying to get a sense of whether or not a Ethereum course is going to make a lot of sense to include a lot of React stuff in it, or if it should really just be 100% Ethereum focused. If it's 100% Ethereum, there's still going to be some web component to it, but it'll be like HTML templating as opposed to React. So it'll be an Express server with Pug rendering or something similar, as opposed to using React on the front end. So just kind of uncertain right now. If you guys have any thoughts about React with Ethereum or just Ethereum by itself, hey, let me know in chat. It'd be very helpful to hear. Anyways, let's try to debug this thing and see what's going on. Oh, I think I might know what's going on here. Let's try going to this one instead. No, not that. Let's try creating a new one then. MetaMask right here is what enables me to actually connect to the Ethereum network from my browser. So I've got a private network locally set up right now. So I'm not actually spending any really real money when I deploy these contracts. It's all fake money essentially. So I'll create a new contract right here, and I should see it pop up in the list. So this contract should now be deployed, but I'm getting the error message that distinctly says that it's not, even though it looks like the contract is being successfully created over here. So here's the transaction that actually deploys the contract. Network artifact mismatch. I am kind of misusing Truffle here as well. Truffle is kind of built around the idea of deploying one single contract to the Ethereum network, whereas I'm trying to deploy multiple copies of the same contract. And so that might be a cause of this error that I'm seeing right now as well. Let's do a little bit of debugging, which in Truffle world really just means looking at the issues. And we get absolutely nothing. Let's try Google instead. Yeah, here we go. This looks good. So this seems to suggest that I'm connecting to the wrong network, but I really don't think that's the case. I'm pretty sure I'm on the correct network here. I definitely do get the feeling that something is up with Truffle, though. I do get the feeling that I'm kind of misusing it. So we can look at, this is the actual contract definition right here. So this is what actually gets deployed to the network, or not quite. That's not accurate to say, but this is the actual contract that I'm kind of working with here. And so we can take a look at the raw contract and see if there's anything that kind of stands out. I'm not sure that there really is. Gatsby, I've not worked with Gatsby. Let me take a look at it. Oh, I see. Yeah, that would definitely be, Gatsby would definitely be appropriate. I think that my goal, though, if I'm going to touch React, it's basically kind of a all or nothing sort of deal, where either I'm not using React at all or I'm using React all over the place. And so Gatsby would definitely be pretty neat. At least we'd be able to, I don't know, kind of simplify the React we are using, because it is a static site generator, and so we would be able to avoid some of the nasty React router stuff. But I kind of feel like I want to do a lot of React or none at all. Oh boy, this is just a huge file, so I'm not really sure I'm going to see anything in here that's tremendously useful. I definitely get the feeling that I'm not. right, so it doesn't really look like there's a lot of stuff going on in there that's specific to Truffle. So still the problem remains here that it appears I'm not able to like get anything from this address right here. So essentially the error message that I see specifically says, hey, you're trying to get access to a contract that has not actually been deployed to the Ethereum network. I'm tossing in the address right here, and this is the address for the just very recently deployed contract that's sitting exactly right here. So maybe we need to take a look at that address and see what's really going on with it. So we do have the address. Oh, I think I know what's going on. OXFB. No, that's not it. So whenever you create a contract, you get two things back. Number one, you get like a transaction receipt. And so this transaction right here is the thing that says, okay, the Ethereum contract was actually deployed to the network. And then the other thing you get is the actual address that the contract was created at. And so I was hoping, well, maybe I'm accidentally working with the transaction here as opposed to the actual contract address. But I see, so 0xFB88, and that's definitely what I'm working with right here. So I'm definitely working with the actual contract address. And so I'm definitely having a tough time figuring out why I'm not able to find it. What we can probably do is read a little bit more into Web3. So Web3.js is what I'm using here to kind of work directly with the local Ethereum blockchain that I'm hosting. So we can probably take a look at some of the documentation and figure out how we can use it to kind of reach directly to the contract that I deployed. Maybe that'll give us a better sense of whether or not the contract really is being deployed. Here we are. This is what we're looking for right here. So we're going to get that big JSON file that I was looking at a second ago. That's called the ABI. ABI you can essentially think of as being an API, more or less. So this little snippet that I just copied expects me to pass in the ABI that kind of defines the contract and says exactly what's going on with it. So here's our Web3 instance. This is the Ethereum manager that's tied into it. We've got the contract ABI. So I need the ABI first here. No, that's not what we want. Oh. Yeah, okay. I see what's going on here. So it was a bad copy-paste, exactly what I thought it was before. So we're getting a list. Here's my server put together. The server has three purposes. First off, it gets a list of all the deployed contracts that have been created. Second off, it returns a blank template for a new contract that we can deploy to the Ethereum network. And then finally, it allows us to push an address to a contract that we have deployed from the browser. And so right now, I was accidentally making a request to contracts, which is a list of all the contracts that have been deployed, when really I wanted to get the definition for the contract that I'm trying to create right now. And so I was getting a list of all the contracts. So it should have been contracts new, like so. So this is going to return the actual contract ABI. Let's take a look at that just in case anyone's kind of curious. All right, so we get res.data. Oops. All right, so there's the ABI right there. So that's what we really wanted to work with. Okay, so now we should be able to take res.data. We get the contract address. We set our provider. Let's do that. We do that right here, that's fine. And then we get the instance. So let's see what happens now. So we will continue execution. Looks like we still got an error message. Let's see if it actually sticks around. Don't want to do the debugger. Huh. Oh, didn't save the file. Yeah, if you guys have any questions about what I'm doing here, absolutely feel free to just ask in chat. Like I said, I'm just kind of doing some experimentation for Ethereum and Bitcoin, or excuse me, Ethereum and React course. And so right now I'm working on a tiny React app that essentially is a like crowdfunding equivalent, and it's pretty full featured too. Does everything that Kickstarter does, I would say. Maybe not everything, but you can collect money and then you can disperse money, all that kind of good stuff. So we're still getting the same error. CrowdFund has not been deployed, even though at this point I know that it has. So let's go back to the old form. Rest.data at address. Finally. Okay, so now we're actually retrieving the contract here, which means we can start printing out some information to the user. So previously we were not printing out anything while we were still fetching details on the contract. Now that we are actually getting the contract back, we can start printing out some information around it. So put in a div. And I actually don't really, I don't know, let's play around with the contract itself and see what we can really do with it in terms of data. There we go. Okay, so here's the actual contract. So the contract itself, you can think of as being like essentially a JavaScript class, more or less, but it represents kind of like, I don't know, I guess a contract. So here's the actual crowdfunding contract. So this is the thing that actually kind of defines the business logic or the rules for my crowdfunding app that sits on top of Ethereum. So I'm defining a contract. The entire contract here is kind of, or the entire idea of my particular crowdfunding app is kind of predicated on the idea of people can donate money into it, but then once they donate money into it, they then become kind of like a person with rights or like a voter on the project itself. So usually when people ever talk about, hey, I'm going to do crowdfunding with Kickstarter, there's always that stigma of people doing these big Kickstarter campaigns and then they just walk away with all the money. They just say, okay, collected the money, but we were unable to actually finish the project. Sorry, but no one actually gets the product they care about. And so my idea here for my crowdfunding contract is that once you donate money, you then become kind of like I think the term that I use for it is a contributor. Oh no, an approver. So once you donate money to my crowdfunding contract right here, you are now marked as an approver. The owner of the contract can create requests to withdraw money from the account, so essentially to spend money that has been donated to the project. But whenever the owner tries to make that withdrawal, they have to make a request, and then some minimum number of approvers or people who donated or contributed money to the campaign have to approve that request before it actually gets sent off or the money actually gets dispersed. So the entire idea behind this project here, or this crowdfund contract, is to do like the classic Kickstarter raising of money, but make sure that people cannot just walk away arbitrarily with the millions of dollars that have, or thousands, whatever it is, of dollars that have been raised. So this is the actual contract. The real important stuff is right here. Once you contribute to it, you then get added into an approvers array. So once you give money to this project, you then get marked as an approver, and you have the ability to vote or approve requests that the owner of the contract is making. So the owner can create a request. So this would be something to say like, hey, I need to withdraw money from the project so I can start building this thing. So they would create the request, and then it would be up to the contributors to then approve that request. And then eventually, after getting enough approvals, the owner can then come back and finalize the approval, which would allow them to actually disperse the funds that have been requested previously. So in terms of actual information to show on the React app side, the intent of this page right here is to actually show some information to the people who have contributed to the contract. I think that what we probably want to do is like show the list of requests that have been made, and then maybe talk a little bit about, or show some information about how many people who have actually approved it so far, and then maybe mark how much money the owner is trying to withdraw and how much or where they're trying to send that money to. Oh, and Ed, thank you on that with the truffle debug. I could tell the transaction was definitely going through successfully, Ed. I know that the contract is being deployed. The issue was that I wasn't able to actually get a reference to the instance, and that was basically just a bad typo on my side. Okay, so anyways, now that we've got a better idea of what the contract is doing, now we want to show some amount of information from it. What's kind of awkward here is that I've got a reference to the contract, but I don't actually have any information about it. We can think of this as being like just a scaffold of a contract, or I don't know, maybe that's not the best term, but basically I don't really have any information that's super usable about the contract yet. I have to actually essentially make follow-up requests to determine how many requests for money are being made right now, who the owner is, I don't know, all that kind of other, how many approvers there are or contributors there are to the project. So doing all that is all asynchronous requests. So right now I'm already down inside of render contract, but maybe before I attempt to do anything else with it, I need to actually go ahead and attempt to kind of fill in some of the blanks here. So I think that I want to do something like, I don't know, you know what, let's go back over here first and just kind of confirm that. So if we call, like, say, owner. So when I try to figure out who the owner of this contract is, you notice how it returns a promise right here. And this promise will actually be resolved with the information I'm trying to get at. And that's the same with all the different properties that are tied to this contract. So the list of approvers, the money that's tied to it, like everything, it's getting access to that information is all asynchronous in nature. And it kind of makes it a little bit of a pain. So I think that maybe what we need to do here is, rather than instantly setting state with the contract instance, maybe we need to also do like a whole bunch of data fetching of pulling properties off the instance and then set those property to state rather than the contract itself. I think maybe we could still assign the contract to state, but we want to also get access to a bunch of different properties off this thing as well. So maybe we need to do something like const owner. Let's get the person who owns the contract. We're going to wait instance.get owner. No, just owner, excuse me. And then we'll add it to state like so. Actually, let's get some ordering. There we go. Okay, so let's try this. All right, so that definitely worked, but I'm not actually printing anything else. So let's print out this .state.owner. All right, so this is the person who actually owns the contract or who actually deployed it. So in this case, that's me. So I am the person with address 62730. That's my root account right here. It was created by Truffle. So that's useful, but not really tremendously so. I think that we need to get some other information here. Now, the kind of awkward thing about this is that getting access to every property off the instance right here, like say getting access to the owner, like I said, that's an asynchronous request. And so I'm talking about what I really want to do here is kind of query for like 5 different properties off the contract at the same time. And if I just list out a bunch of awaits here and say like also get access to, you know, print out all the, I don't know, requests or something, we're going to try to get access to all these properties sequentially or kind of in serial, which makes this kind of loading of data right here take really long. So instead what I want to do is do it all at once. So I'm going to make a new promise.all, something like this right here. Yeah, okay, so that looks better. So then this will make sure that these requests go out at the same time. And we can do a little bit of destructuring to get the result. So we'll say owner and requests. How about that? And then we'll try with requests as well. And for requests, request is an object here, and it represents all the requests to withdraw money from the contract. So rather than trying to put those into the render statement, I'll just log them out and see what happens for now. All right, so invalid number of arguments. Something definitely went wrong here. So requests right here. Request is a mapping. That's what's going on. So request is a mapping, and a mapping is essentially the same thing as like a hash table or JavaScript object. So requests expects me this. I can't just like get a big old object that describes all the requests that have been made to withdraw money from this contract. Unfortunately, with Ethereum, we have to know. Remember, a mapping or an object or a hash table is a collection of key value pairs. And when you're working with Ethereum, you have to know the key of what you're trying to access within that object. So with JavaScript, we're extremely used to writing stuff like, say, const colors with, I don't know, color 1 red and color 2 blue. And we get very easy access to a list of keys here. So I can do something like object.keys with colors. And so I can see very, very plainly what keys are available inside of this object, colors that I just created. But with Ethereum, or to be more precise with Solidity, which is what this language is right here, whenever we create a mapping, which again is like a hash table or JavaScript object, we don't get easy access to the list of keys. And in fact, there is no list of keys. So my key would be a unsigned int 32, or essentially a number here, but I have absolutely no way of like getting a list of all the different keys that have been added to this mapping. And so what I just tried to do right here, I tried to just get a list of all the different requests that exist inside of that mapping. I can't actually do that. I have to actually know about all the different requests that have been added, or all the different keys that have been added to the mapping ahead of time. And so that's definitely a pain. I think that's probably something I'm going to have to fix here in the contract. So I think maybe rather than worrying about that right now, maybe we need to, let's do something like just print out the minimum contribution. So let's do that. Minimum contribution. All right. So then down here, print that out. All right, this should be a little bit better. Okay, so we have an owner address now of 0. That's fine, so it's an address, but it's being incorrectly interpreted as being like a number. And so it's showing up as 0. And then probably the same thing for minimum contribution here. I suspect if we console log these out, they'll actually show up correctly. So this dot state, we just console log it for now. I think I'm worrying too much about printing this information out on the screen, which is kind of not relevant for right now. All right, yeah, so they're incorrectly getting coerced to being strings here, which is definitely not what I want. Either that or, you know what's more likely? No, x and 0, yeah. So basically, they are coming out correctly, but they're kind of getting coerced to bad values here somewhere along the process. Let's not worry about that too much for right now. Let's get the list. Okay, let's do something easy. Let's say we'll get the list of approvers. So approvers is the list of people who have actually contributed to this campaign. So it'll be a list of wallet addresses. So if you send money to my crowdfunding contract, you'll get put onto this list of approvers. So approvers right here, array of addresses. So let's stick that into state. And still, let's see. Let's say number of contributors. And that'll be the state.approvers.length. And right now it should be 0 because I've not yet contributed any money to this particular campaign. Okay, so I think that the exact same thing here is happening. So this is another kind of interesting difference with Solidity arrays. as with mappings. So right here, like I said, we have a mapping, which we can think of as being like a JavaScript object, but it behaves kind of strange. Same thing with arrays. So I've got this list of addresses, which are the people who have contributed to my crowdfunding campaign. But once we start trying to get access to this list, or the actual like list of approvers, it is an array of addresses, I can't just get back the entire big array. I have to actually ask for one particular index within that array. And so what we're seeing right here, again, the same error I just saw 2 seconds ago at the mapping, it says, okay, we've got an invalid number of arguments to a solidity function. What that means is I am trying to ask for the entire array of people who have contributed to my campaign. But the error message is telling me, no, you can't just get the entire list. You have to actually ask for a particular index within that list. And right now, I can't even ask really for an index because I don't have any people in this array. So if I ask for the person at index 0 within the array of approvers right here, I'll probably see an error message as well that says something like, hey, you don't have an entry at index 0. So let's take a look at the contract. I previously had a method on here to return the entire array of approvers, but I think I deleted it at some point. So I think that what we'll do here is we'll create a new function to get a list of approvers. This will be public view, and it's going to return an array of addresses, address array like so. And we'll return approvers like so. Okay, so that creates a new method on my Solidity contract. So now I can get access to just the entire list of addresses at once. I think that at the end of the day, what I'm trying to get at here is not the list of approvers per se, but the number of approvers. So let's say get approvers count. Let's do that instead. I think that makes more sense. I'll make this a unsigned int. I don't think it's ever going to be, so uint defaults to uint 256, which is a tremendously large number, so maybe we'll just arbitrarily cap it and say like a uint 16. That should probably be good enough. That might throw an error here, but we'll see in 2 seconds. So I'm going to restart my network. We'll do truffle compile. Yeah, okay, so I'm trying to convert from uint 16 to 256. We'll just say what the heck, I'll give up on that for right now. We'll come back and fix that. So we'll compile again. All right, so now we can start the network back up. Cool. Okay, so when we restart it, all the contracts should be getting cleared out. So my contract list is now completely empty, which means I have to recreate my contract. So I'll make a new contract, minimum contribution. Oh. Okay, so I gotta fix a little bug with React Router here first. Let's put this into a switch. That should be better. There we go. All right, that's better. So create our contract. MetaMask asks if it's okay to spend my money. Yes, it is. Now here's my contract. We're fetching details on it. And we've got no coded address. I think that's okay. But that likely means, so if we go up, we should eventually see the transaction, but I don't see it up here, which is definitely super concerning. So why would we have not been able to create the actual contract? Let's try making a new contract, see what happens. Here we go. So we got a failure. Let's see what we got. Oh man. Okay, so yeah, I think I know what this is. So this is such a pain in the rear. MetaMask right here is a work in progress. So MetaMask is what actually allows you to tie your Ethereum account to stuff that happens in the browser. The problem with MetaMask is that it's kind of built assuming that your internet connectivity might be like going in and out at all times. And so I just restarted my network. When I restarted my network, MetaMask then tried to, essentially I tried to deploy my contract again. MetaMask did not realize that I just restarted the network and wiped the slate clean. So when MetaMask tried to do an actual deployment of the new contract here, it gave it a transaction number of 10, when in fact I had just restarted my contract, or restarted my network. So the first transaction should be numbered from 0. And so this is probably gonna, we should eventually see an error message that says like something, oh yeah, here we go. So the transaction does not have the correct nonce, account has a nonce of 0, transaction has a nonce of 10. So essentially we have a mismatch here because I cleaned out the network. And this is such a pain in the rear because with MetaMask, we don't have the ability to easily like restart this thing. If I, like say, create a new account or import it, no matter what I do, MetaMask is always gonna think that it's trying to push my contract at index 10 here, when in fact it should be index 0 because I just cleaned out the entire network. And so as far as I know right now, and I did a little bit of research on this, and the research appeared to agree with me, all I can really do is remove the entire MetaMask extension and then re-add it, which is super unhelpful. If there's one thing that I've learned about Ethereum, and I learned this very quickly, it's all a work in progress. It's all a work in progress. And so much of the software around this stuff is just still in active development, and there's still a lot of very like large bugs and very awkward points that are floating around, and MetaMask is certainly on that list. So I have to reinstall MetaMask. So when I restart MetaMask, it tries to connect me to the main network. I don't want to do that. I want to connect to my local test network instead. But I don't think I can do that until I actually sign into an account. So we'll do that right now. All right, there we go. So this is a test account that's automatically generated for me. So now I've got the test account, we can add on our local network, which is hosted at localhost 9545. And we'll save it. And even when you click save right here, it's really awkward. It doesn't actually like do anything. We can actually go back, and then lo and behold, yeah, we actually are now on that network. So now I should be able to actually get this thing sent out. So I do want to restart my server to clear out the list of contracts that the server thinks exist. So this contract doesn't actually exist right here. So I'm going to restart my server to just clear that thing out. All right. So now we have no contracts. So I'll make a new contract. Minimum contribution to my crowdfunding campaign is 1,000. I get asked for approval. Yep, that's fine. So now that thing should be successfully submitted, and I should see the transaction appear in the log. Here's the transaction. Here's the contract address. Now I can go to the contract address. We're fetching details on it, and still we have an error here. I think that I updated my Solidity contract, but I didn't update my JavaScript code. So right here, I'm getting approvers. So I want to get approvers count, do we call it? Let's look at the contract. Crowdfund. Approvers counter. It should have been count, not counter. I'll redeploy in a little bit. We'll leave it as counter for right now so we don't have to reinstall MetaMask again. So now we've got approvers, we've got the owner, and we've got the contract as well. So now we should be able to restart and refresh. And still we have an error. So invalid number of arguments. Why? Got owner. We've got one owner. We know the owner works. Then we've got approvers counter. Let's give this one more shot. Yeah, something feels off now. No number of arguments. So let's forget getting the number. Oh, doesn't like it. All right, so what do we have this time? Binary property length of undefined. Okay, so that's where I had used the number of contributors. There we go. Okay, so it looks like it definitely works without that trying to fetch the number of approvers thing. But we're still getting the error message that says something about not providing function arguments. So we're returning approver's length here. I'm pretty sure that's how we do it with Solidity. Let's check out the Solidity docs. We don't want that. We want Solidity in depth. So these are the Solidity documentation. Top-notch documentation. I'm super happy with it. There's some areas that are a little bit challenging, but in general, it's really just top-notch. I'm really happy with it. So we're going to try to look up some documentation about arrays, specifically working with the length. It should be, just .length. That's definitely working correctly here. I think that technically we are working with a dynamically sized array, but I don't think that they work any differently than a fixed size. Rule of thumb, use bytes and string length for you can limit the number of bytes, blah, blah, blah. Yeah, I think they were probably okay. Writer, this thing. Yeah. Oh, that doesn't feel super great. We could write a test around this, and I think we'll do exactly that. So I do have some tests pre-written for this contract. So I'll make a test file specifically to test the Solidity contract. Let's see, where is it? Test, crowdfund test. Okay, so here's our test. The tests are all written with Mocha, and they just test different behavior of the contract itself. So, for example, it allows people to contribute money to it. It requires a minimum contribution, and allows the creator to create payment requests, all that kind of good stuff. So not that bad. I think that probably what we want to do here. So you can see right here an instance where I'd said that whenever you're working with an array in Solidity, you can't just easily ask for the entire array. So in this case right here, I'm asking for the first index of the array. But because we just created that new method to return the approvers count right here, I should be able to get back the entire, or the number of approvers. So let's say number approvers await instance dot like so. Now I should be able to assert equal number approvers. Let's get our convention here. Approvers count. I think that's best. Count, not counter. And this should be equal to 1 because we've had one person in this test contribute. Okay, so that looks good. So now we need to rerun these tests. So we'll truffle compile. That's going to, so when we compile the contract again right here, we're going to have to We're going to have to go and reinstall MetaMask again because that transaction issue that I mentioned earlier. So yeah, the transaction stuff really is a pain, but that's life. So we'll truffle test, and this will run all the tests that I wrote against the contract. All right, so it definitely looks like we've got something funky here. Yeah, there's something wrong with that, definitely. Definitely doesn't like the get approvers count, even though I definitely did not at all specify any type of argument here. Oh, you know what? Let's see. Ed suggested just a little bit ago, try debugging the transaction. That's actually a great thing to do here, except I think that the issue is that trying to get access to there is no transaction for what I'm trying to fetch right now, because it's the request to actually figure out how many contributors I have is not even making it over to my Ethereum node. That's the issue right now. So Truffle takes that ABI for your contract, which, remember, the ABI is like an API. It describes how you can work with the contract. And right now, this error that's being thrown at present is talking about the error that we're seeing right here is talking, or is being thrown by Truffle. So Truffle is saying, hey, you're trying to call a function here that doesn't actually exist inside the ABI. And so we can't actually debug it using Truffle debug, unfortunately. So we need to actually figure out what is truly going wrong. Let's start off by debugging the tests. I think that's a good place to get started. So I want to only worry about these top tests right now. And the other thing I kind of want to do a little bit of research on is see if we can actually get the length of a dynamically sized array. That's the other important thing. Solidity dynamic array length. Types. Creating dynamic arrays. We'll see the dynamic array length is initialized to 0. And you know what? Maybe the better way to test this thing. I got a good idea. We want to use the Solidity browser. That's going to save us a lot of time. So this is Remix. It's like a browser-based IDE for working with Ethereum contracts. Incredibly useful, just incredibly helpful. So we can actually test this thing inside the browser and see exactly what it's doing. And it saves us a lot of time compared to having to recompile the contract constantly and do all types of crazy stuff, which is a real pain. Unfortunately, it is a little bit slow. So it takes it a minute to load up. Okay, so we've got some warnings, but the warnings don't actually matter. So we want to run the contract. We're going to that. We're going to create it with, actually we don't want to give it any value yet. So we're going to create it with 100. I'll create the contract. MetaMask here is popping up very unhelpfully. We want to, well, we got to reinstall MetaMask anyway, so we're going to remove it right now. Can you use some other language than Solidity? Unfortunately, no. Everything with Ethereum is all done using Solidity. The reason for that is, this looks like normal code to you and I, but all the code right here gets compiled down to bytecode and executed on what's called the Ethereum EVM. And what I just said, I think, is completely unhelpful. That's not helpful at all. So we have to write Solidity because it is a language that gets compiled down to bytecode. So right here, this is the ABI that describes my contract and how it works. This entire JSON file right here describes my contract in whole. It describes everything that it does, everything that I can do with it. One possible field inside of this JSON file is just a couple lines down right here. Here we go. So here's an entry inside this JSON file that, again, describes my contract called bytecode. And so this is the essentially series of very close to the metal operations that my contract executes to behave the way it does. And so this right here is generated by compiling my Solidity contract. And so I can only use Solidity if I want to essentially write an app that's going to run on top of the Ethereum blockchain. You can also see in here, like, we get some source map stuff, and then we get the actual like raw source from my contract is in here as well. But essentially, I have to use Solidity if I want to work with Ethereum. It's definitely unfortunate because I know a lot of people say, "Oh, great, another programming language," and I kind of agree. You know, learning another language is, yeah, hey, it can be fun, but it's also distracting, and sometimes you really just want to get your stuff working and have fun with it. Okay, so we're going to create our contract here. Again, we're trying to debug the thing and figure out exactly why we are not able to get a list of... Okay, so the constructor should be payable if you send value. I think I accidentally sent value to it. I didn't want to. Let's try creating it again. So let's create 100. I don't know why it thinks that I'm attempting to send value to it, because I'm definitely not right now. Create, well, it looks like it's working. So right now I have no approvers, but I can add an approver. Again, so this is the remix tool. So it's for working directly with a Solidity contract inside the browser. What's really interesting about it and what really makes it so fantastic is it allows you to toggle between different accounts. And each of these accounts you can use to work with the contract in some fashion. And so this very quickly simulates like a actual user environment. How someone will actually work with your contract in the wild, which is quite helpful. Would it be possible to remove the data somewhere to reset the extension? Unfortunately, no. Right now, all that data gets cached, and it's somewhere. I don't know exactly where or how that account information gets cached. I did look at a support thread on it on GitHub, and the author of the extension right now basically says, yep, sorry, like, we intend to remove the ability to dump all the accounts and networks that have been saved to the extension at some point in the future. But for right now, if you want to forget networks or anything like that, you just plain have to uninstall it. So very unfortunate right now, but you know, like I said a moment ago, that's kind of the nature of a lot of these, all this Ethereum stuff right now. Okay, so we're going to contribute to the contract as this separate user right here. So now I should be marked as like a contributor. I'm going to toggle back to the original account. This is the owner. And now I should be able to get my approvers count. And it returns correctly 1. So it definitely looks like the contract here is working very well, and it's definitely working the way I expect here. And so because the contract's working here correctly, that really points to an issue with my tooling. So it appears that the contract itself works a-okay, but somewhere between writing the contract, compiling it, and then loading it up inside the browser, inside of my React app over here, and working with it, somehow an error is occurring along that chain somewhere. And so this is something I've struggled with a whole bunch. That's kind of a pain. Again, it is Truffle that takes my contract and kind of makes it available inside the browser. And like I said just a moment ago, Truffle is very much like MetaMask, still a work in progress. So there's a lot of these issues that tend to crop up over time. Something that was really interesting that I found was, you can see this build directory inside my project folder right here. Build is where all my compiled contracts get placed. So I've got my contract called crowdfund right here. That's what we're looking at on the screen. And whenever I compile a contract, it gets built out to this directory right here as this JSON file. And I've noticed that sometimes it appears that if you rebuild the contract, or I should say recompile it, it doesn't actually delete the old version. And sometimes it like adds on to the JSON file or like appends to it, as opposed to just replacing it entirely. And so more than once I've had to manually delete these built contracts and rebuild it again. So at this point, it really feels like something's going wrong with Truffle. So I really want to restart Truffle. And I want to recompile the contract. So I just deleted the compiled version of the contract. I'm going to compile it again here so I know I'm working with something fresh. And then I'll restart the network back up. And then again, I have to install MetaMask again, which is unfortunate, but that's reality. So we will Truffle develop, and we'll also start up our log. And then we'll flip back over here and reinstall MetaMask. I did spend a tremendous amount of time on Wednesday last week, essentially all day, trying to come up with a solution to not have to use MetaMask at all. And I think I've got a reasonable solution to not having to use MetaMask, or kind of like removing it from the flow. The issue, and portions of Truffle too, like just trying to cut Truffle and MetaMask out of this app entirely from a development standpoint. The problem is that at the end of the day, when you start doing Ethereum development, people want to use MetaMask and Truffle. And so even though I spent all that time trying to remove it, I think that at the end of the day, it's something that just has to stay in because people want to learn how to use MetaMask and Truffle. But I'm definitely have to spend a lot of time making it clear the exact limitations of both those things. Okay, so we just reinstalled MetaMask. We re-added our account. And then just like before, we have to make sure that MetaMask attaches to our local 9545 network. So we're now connected to the local network. Here's account number 1 right here. So if I now go back to my React application, okay, so we have no contracts. We'll make a new contract. We'll set up a minimum contribution. I get prompted to approve the transaction. Okay, so my contract is now deployed. Yay, so now it works. Okay, so I don't know if you're still watching stream here, you probably saw like 20 minutes ago, it appeared that I was unable to retrieve the number of contributors. And we saw that error message like literally just 2 seconds ago where I was saying, oh yeah, it looks like something is going wrong with our tool chain because it works in the Solidity browser over here, where I just tested it out. It works here, but it didn't actually work inside the application. And so I said, geez, it sure seems like this is something having to do with Truffle. And to fix it, I deleted all the compiled contracts. And yeah, in fact, that did fix it. So when I compiled the contract, that gave me the built JSON file right here. I then made a change to the contract. I then recompiled it. But for whatever crazy reason that I still have not really been able to figure out with Truffle, it does not like overwrite the compiled version. So I was working with a out-of-date version of my contract, even though I had recompiled it. So I had to manually delete the built version right here, recompile it, and then everything just like magically worked inside the browser. And so that's a great example of Truffle. And this has happened, the only reason I kind of stumbled onto this pretty quickly is that this has happened to me like 3 times before. So for whatever reason, Truffle appears to really not just clean up after itself with compiling, which is unfortunate. But again, with all this Ethereum stuff, like struggling with it to a degree, it's the cost of doing business. There's just not a clear suit, like everything. It doesn't just work out of the box, I guess is what I'm trying to say here. You have to have some knowledge of what's going on, which is good and bad. It's good because that means if you know about this stuff, you're extremely valuable and you could find it easy to get a job, but it makes it challenging for people to kind of approach this stuff. So, all right, so now let's move on to the next thing, which is to figure out why our owner address right here is printing out as 0. So my owner address is being returned. Without a doubt, I know that's working. So here's where inside my contract show component, I've got my component in mount. I get my deployed instance of the contract that exists on the blockchain. I then try to pull out the owner of the contract. And the owner in this case is the person who deployed the contract. So this would, remember, the entire point of this contract is to essentially simulate like a crowdfunding kind of deal. And so the owner of the contract would be the person who is like running this crowdfunding campaign. So if I was that guy who made Star Citizen, forget his name off the top of my head, but if I was the guy who made Star Citizen, that guy would be the owner right here. It's the person who is running the campaign. But as we just saw, that owner, which should be a wallet address, which should be a string, is incorrectly showing up as 0 right here. So it's kind of interesting. If I throw a debugger in here, we can look at the value of it. And we're going to see that it actually is a value. It's not 0 at all. Or at least we should. I shouldn't say that too soon. Oh, I think I might have said it too soon, but we'll see. We'll see. Okay, so owner. Oh man. And I think that one, okay, approvers is now showing up as X. So let's see. Context sent. What is this thing? Ah, there we are. Okay. So this is like where ES6 destructuring goes wrong. So this is the actual wallet address right here. It's getting sliced up by this right here. So I had been hoping that I could destructure off the promise.all right here. This is ES6 destructuring that we see. I cannot, in fact, I think that I have to chain on a .then and then receive all of these different, like the owner and the approvers thing. I think I'll come back to this and I'll figure out the destructure. I want to make sure it works first. I want to like get this thing working, and then I'll come back and figure out exactly what's going on. Okay, so we'll get owners, and just owner, excuse me, and approvers. And at this point, approvers is really approvers count. Let's fix that up at the same time. Approvers count. Oops. And count. Approvers count. And it's no longer approvers length, it's approvers count. All right, let's try this out. Okay, so now we've got our address here appearing correctly. It looks like number of contributors is not. In this case, it actually makes sense because I do not have any contributors. The other thing I just realized, we're now using promise.all in like a classic sense here. We don't actually need the promise.all, or we don't need the await keyword. That's what we want. And that is also, I just realized that's also why that the await on the promise.all itself was not working out the way we expected. Okay, yeah, so this, I think that we're definitely in a good place now. So now we've got another little issue. That's okay. Let's figure this one out. If you're here watching this video and you've taken one of my courses before, you've probably noticed that I don't, maybe you haven't noticed, but I very rarely use debugger in any course. But when I do any development on my own, I am in debuggers just pretty much all day. I throw on a tiny bit of code, and then I use a debugger to pause execution, and then I will essentially write out the code that I really want to write at the terminal, and then paste that over inside my editor. That's kind of a large way in which I do development. But it's something that it's kind of hard to learn in the context of a course in that type of fashion, so I don't always do it in a course. Okay, so we've got instance.owner, and we've got get approvers count. Something inside of here is returning undefined. So instance.owner is definitely fine. Instance.get approvers count is definitely a function as well. Let's actually call these things and let's see what happens. Interesting. Well, let's continue execution, see what happens. Okay, so it definitely is coming back here. But at some point in time, something is ending up as undefined, but I can't quite imagine what is going wrong. Promise.all is definitely not undefined or anything like that. We're definitely fine in that regard. Let's fix up let's get this back to async await syntax. I don't think that's related, but now that we worked out the issue with that, we'll flip back over. So that's better. Do a little cleanup. Okay, let's try this out now. One thing that you'll also notice about a lot of the Ethereum stuff very quickly, I don't know if you saw on the console there, but it said big number whenever I was trying to log out those two numbers, which is kind of interesting. So big number is an actual library. Go to big number JS. So when you're working with Ethereum, you are very frequently working with very, very large numbers, like very large. And JavaScript doesn't do quite so well with large numbers. And so Ethereum in a JavaScript environment, or I should say it's really a library called Web3, works with big number JS to handle any large numbers. And so what big number does is essentially it takes your number, very large number, and it prints or essentially stores it as a string, kind of, not quite. And then whenever you do any type of arithmetic on that number, you're calling, like, say, equal, let's see, what's a good example here, minus or multiply. Well, I see minus right here, times, there we go, there's times. So you're working with numbers that are kind of wrapped in this big JS library. And so you see that all the time when you start working with Ethereum and Web3. So half the time you don't actually have a good sense of what the number is. As soon as we hit a debugger again, I'll show you guys an example of that, and it should be interesting. So we're still getting this thing with undefined is not a function here. So, I mean, promise.all is definitely not the issue. We've definitely got instance.owner. We've got instance approvers count, get approvers count. We just saw both those working correctly, but it really appears that something is going very, very wrong here. So what could possibly be throwing an error here? Let's try pause on exception. Let's see what happens. Yeah, this seems very, very off. Why does it think this is not an instance.get approvers count? How interesting. So something is definitely going super wrong in here. But that's a function, and get approvers count should be a function as well. That is also a function. Gee, do I have like a tiny typo in here? Instance dot get approvers count. Yep. And the browser's starting to lock up here. As soon as I start using the terminal too much, it eventually starts to go downhill very quickly. So those are functions. Huh. So something is definitely very, very off here. And I really get the sense that it's tied to like this await here or something. No, that can't be the case. But why would promise.all sometimes be throwing an exception? Send the methods inside the array. You're saying like place the two method calls inside of an array like so. Yeah, am I calling promise.all just entirely incorrectly here? Is that, let's look up some documentation. You are so correct. I think this is totally my error. I think it should be inside an array. I think you are totally correct. Oh, and it actually like appears to have resolved. Oh my gosh. You're so right. This is actually the first time that I've been streaming coding, and I was kind of afraid that would make me nervous and lead to silly mistakes, and I think that did just happen. Hopefully I'm not making any other silly, embarrassing mistakes. Oh well. It's still kind of fun here to kind of talk through this stuff and describe it as it's happening. So objects are not valid as React children with keys. So this is that big number library that I was just mentioning. So I'm trying to just print out inside of the div right here, the owner and this approvers count. So the issue is probably approvers count right now. I think that I just console logged out the state just a second ago. Well, my browser is really starting to crash. I think that I'll restart it here in just a second. Let's actually do a restart right now. Yeah, this is pretty bad. All right. Watch this. It's going to be like nice and fun and speedy once I start it back up. Anyways, so we just got that error message saying like, hey, you can't print children or object as children with React. So right now, approvers count you look at this variable right here, and to my eye, sure, it looks like it's supposed to store a number. And thinking back to the solidity contract that I made just a little bit ago, it's definitely a number. But again, we're making use of the big number JS library here. And so approver's count is actually an object. It is an object that is wrapping a number. And that is done, again, because JavaScript doesn't work quite so well with very large numbers. And anytime that Solidity starts, or excuse me, Web3 starts working with a number, it assumes that the number might be very large. And so it stores it inside one of those Web3 objects. So let's go back to localhost 3000. We'll go back to the contract. Okay, so we've got the same error here again, which is totally fine. So yeah, objects are not valid as React child. And then if we look at our state, you'll notice that we've got this approver's count right here. So this is the big number library. And so it's got like this property C, E, and S. So I'm not going to pretend to know exactly what big number is doing internally to store these numbers. I can tell you in this case, I think the value should be either 0 or 1. I don't know. So maybe S right here is for the ones place or whatever. Essentially, to actually get something that's printable here with a big number, it's really straightforward. All we have to do is call toString. So that's going to take the number, which might be very, very large, and it's going to cast it to a string, which can be safely worked with and printed out inside of JavaScript without worrying about like any issues with very large numbers. And so when I call toString on there, yeah, you'll notice that I correctly have number of contributors being set to 0. Ooh, all right, so that was way more work than we thought it was going to be. I did lose my YouTube chat, so let me open the stream again very quickly. And we'll see what's going on. So we've got the contract now working for at least printing out this tiny bit of information, but I still don't really have a good ability to actually like work with the contract directly. So if you're just joining here, the purpose of the Ethereum contract that I'm creating is to do like crowdfunding campaign. So I'm now printing out the person who created the contract, the number of people who have donated to it. I think that I could also probably print out really easily the number, or excuse me, the amount of money that has been contributed. So maybe that'd be an easy one that we'll do very quickly here. Let me just bring my chat for the stream back up. There we go. Okay. So I heard someone say try Firefox Quantum, probably addressing the debugging stuff that I'm running into here. I think that some of the speed issues that I'm running into is actually because of the stream. It's kind of what I suspect. I don't know. I could be totally wrong here. Whatever. I will look into some other alternative debugging stuff because, yeah, it does get really tiresome how quickly this stuff lags out sometimes. Anyways, okay, so we're back to the state here. Let's see, we've got our contract. The contract by this point is an instance. I believe that the instance should have the ability to fetch the amount of money that's actually tied to it. And we can look on the, what the heck, let's throw our debugger in again. And we'll take a look at the contract and see how we're going to pull out the value. So contracts in Ethereum are helpful not only for like kind of putting some code to money management and managing money with code, but they also store as like essentially a value store or a wallet. So a contract can have Ethereum coins or Ether assigned to it, and that's what we're doing in this case. We are sending money to this contract. So anyone who is donating or like contributing to this crowdfunding campaign, they're actually sending money to the contract itself. And so if I'm working with this .state.contract, so here's the object that represents the deployed contract right here, we might be able to get, no, looks like we don't have anything about its value on it. That's really fine. We know the address of the contract. So the address right here we can think of as being like a mailbox of sorts that belongs to this contract. It represents where the contract is deployed to. And so we can use the Web3 library, which is kind of our portal into the Ethereum blockchain. I think we can do get balance and then pass in this .state.contract.address. And this little get balance method will give me the balance at some particular address. In this case is the address of the contract. Get balance can also be used on user accounts as well, but in this case we're going to use it on the contract. And then once we get that back, we'll console log. And we definitely don't like that. Oh boy. So I was complaining about MetaMask earlier a little bit, and I'm going to complain again. Oh man. So, some of this stuff is mind-boggling. So right now, I've been saying Web3 is kind of like our portal into the actual blockchain and pulling out information. So here's the real fun thing about Web3. Web3 has version like, I don't know, 2, or like 0.2 out right now. So there's version 0.2 of Web3, and then there's also a beta for version 1. Certain libraries that make use of Web3 are making use of version 0.2 right now, and then certain libraries are making use of version 1. So Truffle, for example, and I believe MetaMask are both using version 0.2 of Web3. So I've been spending a tremendous amount of time working on my own projects with version 1. And so when I start to write code like this right here, this is code that is meant to work with version 1 of Web3. But I get this error message essentially saying that, hey, you're calling this method incorrectly. And that's because Web3 right here, this is an instance of version 0.2. And we can probably check that out really quickly here by looking at Web3 version. Yeah, so 0.20.2, which is the older API that we're working with here essentially. And so I can't make a call like this. Instead, I've got to do something like, I don't know, give it a callback function essentially, and we'll console log error and value. And we very unhelpfully get undefined here, but it's probably because we're paused in execution. So here's another great example of seeing big number. So V right here is the value of this contract at this point in time. So again, I'll call toString. I think I might have, no. So now we've got cannot read property. Oh, okay, well. So I exited the debugger, which means we don't have access to state anymore. But okay, whatever. I'm pretty confident that it's working the way we expect. So I think that we'll just add that in here to get the balance. Now, what's really awkward about using these different versions of Web3 is that, of course, we want to work with promises wherever possible so we can make use of async await syntax. And so that I don't have to work with callbacks, because that would really mess up this function right here, which I'm trying to use as my place to get a lot of information about one particular contract. So now, specifically, just only 100% only because I'm making use of this earlier version of Web3, I have to add in that get balance call. And after I get the balance, I have to print out the balance, or I have to make use of the balance inside of a callback. So I'm using a callback here as opposed to using the await syntax. And so I could do something like using promisify on this function right here, but I kind of want to just get this working for right now, so whatever. So we're essentially going to do address, error, balance, and now I only know the balance inside the callback, so I have to put the set state inside the callback. So as you can tell, this is just not the smoothest thing in the world. So we'll add that onto the set state call. And now the other problem with the get balance call is that, again, this is an asynchronous call. Just like getting the owner and the approver's count right here. So now I am in a situation where I'm definitely making 2 serial or sequential groups of requests right here. So essentially we're going to reach out to the my Ethereum local node and get this information. That's going to be one request, and then I have to do another follow-up request for this stuff right here. So that's super unideal. And I think I'll go back and figure out a way to kind of group all those requests together into one at some point. Okay, now I just I'm talking too much and I made a silly mistake. Oh no, it should just be instance. No, something's wrong here. Yeah, I've got access to the instance. Get balance is not a function. Oh, okay. Oh man, you guys are not going to believe what this is. Okay, so just a second ago, I hope this isn't what I think it is, but let's take a look. So we got Web3 version that I was complaining about just a second ago. We got Web3 version 0.2 right there. But I think inside my code base, I might be actually working with a different version of Web3. So let's see if that's the case. Oh, that's going to be so awful. You got to be kidding. Okay, thank goodness it's not. So something else is going very wrong here. I know what it is. I just have to do web3.f. I think I'm talking too much and not focusing on the code enough. Okay, don't care about the debugger anymore. So we should now have the balance assigned to state. And so we should now be able to print out inside the contract div, I don't know, like current balance or something like that. The balance, again, the balance here is like in the context of a crowdfunding campaign. So this .state.balance. This is all about crowdfunding. So let's see. I want to print like, basically the big number that says like, hey, here's how much money people have contributed right now. Let's see how Kickstarter does it. I know it's up on the top right-hand side. The one thing that my contract is not doing, however, is it doesn't have like a funding limit that's a minimum. I thought that was kind of like just a little bit unnecessary. If you guys disagree with that, I could always go and add that in. But what I really wanted to show inside of my crowdfunding contract was how to essentially give the donators some control over their money after it gets donated. Okay, so they call it, they don't really label the total here. They say just like pledged. Maybe we should do that. We'll say like pledged, BG. All right, so now we should be able to printing out. I think we're going to run into an issue here, maybe again, of printing out a big number. Yeah, I think we're going to hit that again. Okay, so again, big number library. So it should be this .state.balance.toString, like so. All right. So nobody has actually contributed any money yet, so we have a pledged value of 0. So no money assigned to this thing yet. When we print out the balance right here, I'd said, oh yeah, we're working with really large numbers, really large numbers, really large numbers. So the really large numbers are always talking about like values of Ether. So whenever you hear about Ethereum, it's always tied to money, right? Everyone's always talking about like, oh yeah, what's the Ether price right now in US dollars? So if we go and look at that value, it's up at $481 right now, which is, holy moly, that's insane. It was like $300 very recently. Anyways, this is US dollars that it costs to purchase 1 Ether. But an Ether is really not the unit of measurement that is used in general inside of code that you will write around these contracts. Instead, it's something called Wei. Wei spelled W-E-I, so Wei like that. So whenever I'm talking about like these big numbers, it's because we usually work with Wei. So 1 Ether, and Ether is like the value that you always hear about in the news, and whenever someone's talking about US dollars, they're always talking about Ethers. But an Ether is like a unit of measurement, essentially. Maybe it's like a magnitude, I guess. It's like a kilometer to a centimeter or a millimeter. So a Wei is what we usually make use of inside of any code that we write. And so whenever I'm saying here like, oh yeah, big number, it's because this right here, this is what our balance is eventually going to look like. So if someone ends up donating like 200 Ether or 200 Ethereum coins or whatever you want to call it to our crowdfunding campaign, we would have like 200 Ether, but in the code that we write, we would be working with like this much Wei is equal to this much Ether right here. And so that's really the purpose of the big number library. Because if we start doing any type of arithmetic with this number right here with JavaScript, things are going to go south very quickly. So here's a great example. Okay, prove my point right here. Yeah. So this is why we use that big number JS library. Exactly this right here. So big number is designed to allow you to work with numbers this large in JavaScript and do numeric operations like subtraction, addition, multiplication, division without having literally exactly this right here happen. Let's see, like, okay, then we start getting some significance. Yeah, so that's why we're making use of big number all over the place here. Anyways, let's get back to it. So we're printing out the balance here. That's great. We still don't have any way to actually contribute to the campaign though. So I think that's probably the next thing we do. So I don't know, let's put on just like a button. Actually, it should be a form because we need to specify how much money someone can contribute to the campaign. Let's do a label. We'll do like, I don't know, an H4 just to label it. This little form right here to contribute to the campaign should absolutely positively be a separate component. So I'm definitely going to come back here and do that in a little bit probably. So This will be our submittal function to actually donate to the campaign. And then we need to actually give ourselves the ability to contribute. So we'll contribution, I don't know, I think that's probably good enough. So contribution, that's the piece of state that we really care about here. State.contribution, and on change, all right, so that looks good. And then we got the on submit. So let's just make sure we didn't make a typo here really quickly, because we probably did. I think I mislabeled the, yeah, down here, E. All right, so now we've got the ability to contribute, and of course we should probably put a button on here as well, just to make sure it's really clear what's going on. Contribute. There we go. Okay. So we want to allow someone who is like visiting this page right here, because this is basically going to be where we like advertise the crowdfunding contract and say like, hey, give us your money because XYZ, you know, whatever it might be. So this right here is really our ability to allow users to contribute some money. So I want to make sure that if a user puts some money or some amount in here, like, you know, 600 or 6,000, whatever it might be, first thing to keep in mind is that we were just talking 2 seconds ago about the difference between Ether and Wei. So the number that we are entering in here right now is in Wei. So 6,000 right here is not 6,000 Ether coins. You know, I'm not donating like 24 or $240,000 right now to the campaign. This would be an amount of like penny, like fractions of a fraction of a penny right here. So it's just like a total, for example, value. Someone just asked about React Native. Are you talking about like Ethereum in the context of React Native? I did think about that a little bit. The problem is that a lot of the tooling around this stuff is like so tenuous right now in a web environment that I think that throwing React Native on top from the get-go would be very frustrating, really, just because of the tooling and the libraries and just the stuff you'd have to deal with. The other thing to keep in mind is that right now, the way in which Ethereum is accessible to a common person right now is largely through the MetaMask extension or through a Ethereum browser like Mist. And so if we expect people to work with our application in a meaningful way, right now today, just to make sure we are making our app available to the largest group of people possible, I would really want to make sure it's people who are making use of MetaMask. And so that kind of precludes making use of React Native right now. Hopefully that changes at some point, because all this stuff gets way more interesting when you're on mobile, way more interesting than it is in the browser. So hopefully we do that at some point. All right, so anyways, back on track here. So we're contributing to our crowdfunding campaign, 6,000 Wei. So I need to essentially take the current user, like the person who is viewing this page, or essentially the person who is logged into MetaMask right now, that account, and I need to initiate a transfer from that account to my contract for a value of 6,000. So luckily, this is something that's actually like pretty straightforward. I take that back. Maybe it's not straightforward. I don't know. Let's give it a shot. So first off, we definitely know we want to set up a transaction. We're just going to like web3.eth.send transaction. I guess this isn't that bad. So we're going to send a transaction here. It's going to be from the current user, which will be web3.eth.accounts@0. This is a line of code right here that's going to break with Web3 1.0. And maybe even breaks right now. So web3.eth.getAccounts. Okay, another example of where we can't make use of a promise with Web3. So let's do this like so. Oh, I'm signed out. That's why, of my MetaMask. Let's unlock. Okay, let's refresh now. So now I should be able to, oh, no, can't do that. Can do that. Okay, so there's our accounts. We can also do web3.eth.accounts@0. That should work as well. So this is a line of code right here that will not work with Web3 version 1.0. So I'll probably stick with this right here, where I'm going to like basically do a query for Actually, I can't do that right now because I can't make, well, I would have to use a callback. And so I can't write it with a promise, and so it wouldn't work right now with Web3 1.0 anyways. So yeah, we're just going to hard code it like so. We're just going to do that. But we will do a little check here, and we'll say that if there are not any accounts, essentially we should do a little bit of error handling right here. We should show some message to the user that says something like, hey, you can't contribute to this if you don't have a MetaMask injecting your account information right now. Okay, next thing to do is we're going to this .state.contract.address. So when we mount this component, we fetch the actual running instance of this contract, and we set it on our state somewhere right here. So this is our contract. We can get access to the address by that right there. And then finally is the amount, which we specify as value. And that'll be this .state. I don't know, what do we call it? Contribution? Yeah, contribution. Contribution. You'll also notice that whenever I'm working with values here, I am marking it as a string for exactly the same thing as the big number JS issue. If we were treating this contribution as a number, if user starts to type in like 2 ether, but remember this is like the entry here, the units here are way. So if they start to type in 2 ether as way, things are going to get nasty really quickly here. So instead, we're just going to always treat the thing as a string. We don't really have to do any math on these numbers anyways right now, so it's not a big deal, whatever. Okay, so now I should be able to contribute. Let's do like 6,000 way. And nope. So, okay, yet again, we're getting bit by this callback stuff. All symptoms of Web3 version 0.20. So I have to make sure that I add in the callback function here. I don't know I think that the callback values here are probably error and then like some type of like transaction receipt. Call it the transaction, whatever. We'll just console log out for right now and see what we're dealing with. Okay, so let's try this now. So we'll contribute 5,000. Yay, so it pops up MetaMask. So MetaMask is saying, hey, these people want to contribute or like want to take some amount of money from you. You'll notice that the amount is marked as 0. This is probably actually okay because again, we're working with way here. So we are working with 5,000 way, which is like literally too small to show up correctly on MetaMask. Maybe we should change this input right here and have it be like really an ether input rather than way. I think that probably makes the most sense. So we'll do that. We'll test this first and we'll try that out. Okay, yeah, so it won't even like kick in here. Specify the gas. Yeah, and so we're just ran out of gas here. Let's try that again. I think I just wasn't reading closely enough to see what was going on. I think that we specified a gas. Oh, we specified a gas limit of 0, which is definitely not what we want. So essentially, we just did not have enough gas to actually complete the transaction. I wonder if this is, yeah, because this is definitely in way. I don't know, let's put in just like an arbitrary amount. That should probably be enough. No. Invalid opcode. Okay, so this error message right here, invalid opcode, is actually not bad. It means we are sending money, but something essentially went wrong during the transaction. So this is one where we can actually start to make use of Truffle's debug stuff and see what went wrong. So we can debug that transaction. So it's really interesting here. So it just halted right away. Okay, so it's probably an out of gas thing. So I think that this is all like symptoms of not like essentially handling these values as way as opposed to anything else. So I think that we need to essentially like fix that up. What's the best way to do this? So let's first really make sure that we are specifying the correct value for the contribution itself. I think that's a good place to get started. So we'll do like 5,000. So 5,000 is definitely showing this 5,000. So what I would like to do is probably have this entry right here be in terms of Ether as opposed to Way. So let's first make sure that's really clear to our user. So down inside of our form, I'm going to contribute in Ether. Okay, so now we're definitely working with Ether. Now we need to make sure that when we try to kick off the transaction, so whenever we send a transaction right here, this is supposed to be in terms of Way. However, we're now saying that contribution is Ether. So we need to convert this from Way over to Ether. This is another thing that we would use Web3 for, and this is another thing that definitely breaks between version 0.20 and version 1, which is just not super fun. So I think version 1 utils is this utils module right here is how we convert with two-way. So this works with version 1, but with version 0.2, I believe it does not. It's like some other function we have to deal with version 0.2, and I do not recall what it's called off the top of my head. I wonder if it was only added recently. I really hope that's not the case. I think we have to look at some documentation two-way. Oh, well, it looks like it's on the Web3 two-way. Like so. Oh, okay, there we go. Okay, so 1 Ether converts to that many Way. Now I've said several times, we're working with like a string here of 1. So yeah, that looks like it's working out just fine. So we should be able to call right here web3.toWay. We have that many coins, and we need to specify that it is Ether that so we're converting from Ether over to Way. Now, hopefully that's going to kind of help us out with that transaction issue that we saw just a moment ago, but I'm really not going to cross my fingers here at all. So I now contribute 1 Ether. Okay, so something is definitely going wrong here, big time, because we've got an amount of 0 right here. And so I'd said previously, oh, well, it's because MetaMask is not showing that very small amount of Way correctly. And clearly that's not the case here. Clearly the issue is something is going wrong with the transaction creation. So I got send transaction here. I'm thinking this has got to be another issue with Web3 version 2.0. Yeah, you can see up here at the top, these docs are for version 0.2. And if you're using version 1, you're going to go somewhere else. So let's make sure we're using send transaction correctly, because I get the feeling we're not doing that. So we have from, to, and value. Huh. So it definitely looks like we are doing things appropriately. We are specifying where we're sending it from. We are specifying where we're sending it to. And then we are correctly specifying the value or the amount of Ether that we are attempting to send. Let's do this one more time, just really confirm. Yeah, something's definitely off here. Oh, you know what I think is going on? This is, man. Okay, so this is MetaMask in action right here. So I didn't know MetaMask did this, but obviously it does. So I've been like testing this transaction sending right here. That queues up transactions from MetaMask. You can see right here, 1 of 3. I've queued one. Here's transaction number 1 that I queued because I'm in this like testing process. Here's the second one, and here's like correctly 1 Ether, and then here's like 1 Ether here too. So let's clear out the queue by hitting reject all. So now I should be able to hit contribute again. Okay, so now we see 1 right here. All right, so that's much better. Now you will notice that I've also got a gas limit. Gas is essentially how much money we're willing to spend to actually like commit this transaction. So gas limit of 0 is definitely not appropriate. I'm going to get a better amount here. So we should be able to take, and that's defaulting to 0 again. I definitely don't like that. Huh. Well, let's go back to the other contract, and we'll try putting in a reasonable value. So I'll contribute 1 Ether coin, and I'll give it a gas limit of, I don't know, let's just put in like 50,000 like so. Let's try that. Yeah, so it definitely looks like we're running into an issue here. So this invalid opcode error that I'm getting is definitely with regards to gas. And again, gas is essentially how we pay for code to be executed on the Ethereum blockchain or the Ethereum virtual machine. So let's debug this thing again and just confirm that's the case. So debug. And yeah, so this is likely an out of gas assertion right here because it just crashes out immediately as soon as it starts to run the contract. So I think it's definitely an issue with gas here. Let's pull our contract into that Solidity browser again and just take whatever gas value that thing is using. I've definitely not mastered the idea of these of gas values yet. I'm definitely not able to just guess what it might be off the top of my head. So we're just going to steal from Remix here and see what they are making use of. All right, so here's our contract over here. It's compiling the contract, as you can see. Hopefully, and I think it might be frozen. Hopefully nothing's going, okay, there we go. Thank goodness. So I think we specified a gas price, and we've got the gas limit. So something's definitely weird here. Let's see. What's our gas price? Gas limit, gas price. Let's try putting in a value here again. All right, that looks reasonable, and then I'm willing to pay 2,000 per step. Yeah, something that very strange is happening. So you'll note the gas that I specified definitely got sent. Oh. I think I know what's going wrong here. We are sending a transaction that is going to a contract. We are definitely, let's see if that amount actually ended up over with the contract itself. So we've got a pledge value here of 0. So it's still pledged. Something is definitely going wrong with sending money to the contract. Send transact, yeah, something's definitely going wrong. I think I'm using the wrong function. I think that I do not want to use send contract at all. I want to use something else to send money directly over. I think that's what's going wrong here. I don't think I really want to send or to create a contract, or excuse me, a transaction, send it. Although I'm not entirely sure how I would send money to a contract otherwise. So that's definitely something we need to figure out. Oh, you know what? I think I know what's going wrong. I think I know. I think that this might not, let's look at the value of 2. I don't know if that's it, but I definitely want to confirm that we are putting the correct address into this thing. Do we bind this thing? Do we have access to state correctly? Yeah, I think we do. Yep, there's the on submit. But the way that the send transaction right now is behaving, it definitely is making me feel like we might accidentally be trying to create a contract. I think we would have seen a different error if that was the case, but what the heck. Okay, so unfortunately, that's not the case. So the address here definitely matches up with the contract that we are trying to send money to. So, darn, that's definitely not it. Well, you know what? There's one easy way to really figure out what's going on here. So back over at the Solidity browser, I'm going to create a new instance of my contract. So this will create, Solidity, I really want you to go away. There we go. All right, so we'll create. That looks good. So we now created an instance of our contract. So here's the instance right here. Now what I want to do is attempt to send some value to it. And that's all I want to do. I just want to send a value to this thing. I don't want to do anything else. But I've never actually done that before inside the Solidity browser, and so there's going to be a little bit of a learning curve in here. So I'm going to still pretend I'm the same person, but I want to somehow, I think this is it. Enter contract's address. Yeah, that's exactly what I want. So I want to get this contract's address. Okay, so there's the contract's address, and I'm going to attempt to send some money directly to it. So let's clear out the log here, and we're going to see exactly what happens. There we go. Okay, so it definitely looks like we got an error here as well. Yeah, invalid opcode. So something is definitely very wrong with sending money directly to our contract. It's like completely refusing to accept money, which is super interesting. It also appears that I've now got like 2 instances of that contract in memory, which is also not very, very good. Looks like we have someone in chat with a problem with React Router and Redux with versions that are incompatible with each other. So if you're working with React Router and Redux, there really absolutely positively should not be issues with versioning between those two. So any version of Redux should work just fine with React Router. So if you're running into some type of issue, if you're seeing some error message, chances are something else is going wrong. You should be able to use React Router version 0.14 or version 1, version 2, version 3, version 4, any version of React Router with just about any version of Redux. And that goes the same with the React Redux library as well. So if you're running into issues with that, definitely let me know in chat exactly what's going wrong. How long am I working with Ethereum and React for? I should probably take a lunch break here. Maybe I should do that right now really quick. But I'm going to be on for like probably another 4 or 5 hours finishing up this app today. If you mean like in general, I'm going to be working with React and Redux, or excuse me, Ethereum for, I don't know, like the next month or so. So I don't know, like I said, this is the first time I'm streaming as I work through this stuff, so I don't know if I'll continue to stream or not. Let me know if you think I should. I don't know if I'm providing you guys tremendous value here. Hopefully it's somewhat useful. This is all, I can tell you, this is stuff that you're going to eventually see inside of a course, like on January 1st. So you are kind of getting a sneak peek at a new course here, I guess we could say. Erkebulin, I apologize if I'm mispronouncing your name, Erkebulin. If you're still running into issues with versioning between React Router and Redux, let me know exactly what that error is, and I can certainly help you out. If I seem like I have good knowledge of what's going on, well, I've been working with this stuff for like a while now, but I don't call myself a master. There's still some stuff that I am trying to figure out. Yeah, I'll put my email in chat right now. So you can just email me your stuff directly. Just if you send me an email asking for help, do tell me, just in your email, say that you were talking to me on stream, because I do get a lot of emails, and if I don't know that you're the same person, it might be, I might not connect the dots there. Anyways, interesting to see how I code and debug. Yeah, like I mentioned just a little bit ago, unlike when I'm like recording for a course, I really don't use debug statements that often. But when I'm actually doing stuff on my own, oh man, I am probably about like 60% of the time sitting inside of a debug statement, especially when I'm trying to like really figure out something myself, which I guess is the definition of debugging anyways. Yeah, I spend a tremendous amount of time on a debugger trying to figure out what's going on. And I also just click all over the place as well, which I really have to tone down during a course as well. So I apologize if I am clicking around way too quickly here for a stream, but I am trying to figure this stuff out. Okay, so I'm going to assume that email is going to come here, and we are going to figure out what's going wrong with React Router and Redux versions. So we'll take care of that in a couple minutes. But in the meantime, we're going to figure out exactly what's going wrong with this stuff right here. And you know what? I just realized exactly what's going wrong. So this is why I guess talking through stuff on stream is probably really helpful. So, I've been writing this code inside the form thinking, oh yeah, we need to just like send money to the contract and that's it. There's like nothing else going on here. That's absolutely not correct. So maybe calling send transaction is correct for like, just sending money to the contract, but what I really want to do here, here's the source code for the contract itself, the crowdfund contract. So I am totally blanked out here. I had already written a method on the contract itself to allow people to contribute to the contract. So this is how you're supposed to contribute money to a campaign. The contribute function. Yeah, that totally makes sense. I completely forgot I put this in here. So rather than sending a transaction and trying to like transfer value to the contract itself, what I really want to do is call contribute. YouTube is saying that I have stream health issues and it looks like the video is frozen. Hopefully it's, oh, it's not. I think we're okay. Yeah, I think we're okay. All right, let's keep going anyways. Okay, so down here, we definitely do not want to call send transaction anymore. That's completely incorrect. So let's just, let's comment that out for just 1 second because I probably do want to make use of that code in just a moment, or at least be able to refer back to it. So what I really want to do is get access to this.state.contract, which is my instance, and I want to call on there contribute. And I probably want to contribute some amount of money. That is where the value property is going to come into play. So we're going to call value here, and we're going to toss in this amount of money like so. All right, that's looking so much better than it was before. And then just as before, we will attempt to console log out whatever happens inside of the callback function like so. So we can just end up contributing multiple times if we need to. That's totally fine. All right, so let's test this out now. Let's make sure we actually save the file. Yes, we did. So we're good to go. All right, so now here's the moment of truth. We're going to attempt to contribute 1 ether. Oh man, you're kidding me. Invalid number of arguments to solidity function. So when we call contribute, we should be able to pass this object along that specifies the value that I want to send. But I definitely, I think this might be a case where this, well, let's just test this out rather than having to try to explain it. It's probably easier to just toss the code on and test it very quickly. All right, so again, we're going to try to send in 1 ether. Nope, invalid address. So why is this an invalid address? And whose invalid address is it, perhaps more importantly? Let's check out our contract. Yep, here's the contract. We've fetched the correct contract. Let's contribute. Nope, still something going wrong here. So we have an invalid address. If you've been on stream, you'll know that we saw this error message a little bit ago. And it was in the context of some stuff up here. And the issue was that I was not actually like working with an address or a contract at all. In this case, that is like just no longer the case. In this, like we're now at a point where everything should be, like we should definitely be working with an instance of the contract right here. That should definitely not be a problem. Nonetheless, hey, we've been running into issues, so let's console log out this thing and see what's going on. And then we can leave everything else around. All right, so again, we're going to attempt to contribute 1 ether. Console log this thing. We're attempting calling contribute right here. A lot of the documentation around Truffle says specifically like, oh yeah, use this call function right here as opposed to trying to call the function itself. I think that I kind of want to just try that out. So rather than calling contribute directly, let's call a call like so. The other thing I want to do is this is a great example of where we can take a glance at the contract ABI that we've spoken about several times. So here's the compiled contract right here. And so here's the ABI, so this describes all the different functions that we have access to inside this contract. So we've got this request section. What I'm really looking for is the method called contribute. That's what I really care about here. So let's take a look at what the contract thinks it should be. Okay, so contribute should take no inputs and return no outputs, which is exactly, I completely agree. That should definitely be the case. I am trying to call it with an object right here, but this is a configuration object that should be used to like specify the value that I'm trying to send into it. Screen console log, we definitely don't need that anymore. I want to try this just one more time just to make sure I'm not going crazy. Do I use lint rules usually? No, I do not. Linters, without a doubt, would save me a lot of time. I do use prettier, if that's anything. I use prettier, but I don't use a linter just because a linter you usually want to have like per project settings. And I just work on a lot of different projects so frequently that trying to manage all these different rule sets between different projects would be a pain. You can set up global settings or global defaults for ESLint quite easily, but a lot of times the problem with that is that you might be working on one project that's making use of like ES6 or has certain coding standards, and so you'd want to use some specific lint configuration with that, but then you can move on like 5 minutes later to another project that has a different set of rules, and all of a sudden, now you need to go ahead and attempt to do things differently, or excuse me, use a different set of rules. I got distracted there because it now very magically appears that our contribution function is working here, which is completely unexpected because we basically changed like no code. I have no idea why it would suddenly be working when it definitely wasn't. Oh, it's because we did add in that dot call. I think that's probably got to be what it was, the dot call right here. So dot call is great. I guess it looks like things are going a-okay, but the issue now is that our pledge value is definitely not being updated, also along with the number of contributors right here. So it looks like something is not quite going the way we expect. We could check out our logs over here. Yeah, okay, so it definitely looks like something's not actually like the contract, or excuse me, the contribution is not actually being sent here at all. So we're still assigned to the account correctly. So contribute one. Yeah, we're getting back this like empty array here. So something is definitely going very strangely. Another question, seems like a lot of Node.js developers use plugins. Do you see this as a problem? C#. Now, when you say fintech, when you say plugins, are you talking about like linters and whatnot, or are you talking about like libraries and modules? Let me know which one you are referring to. I'd be interested to hear. Okay, so back on track here. So we're trying to call contribute. It looks like the function itself is being called successfully. But it appears that the console log comes up back as empty. And the console log coming back as empty is actually not bad. That's actually kind of good here. But the fact that we are not seeing an increment in the number of contributors or pledged, or for that matter, we're also not seeing MetaMask pop up. So like basically the method here is really not being correctly called. Even though we're calling call and it's definitely not throwing an error. So something is very much, again, not going according to plan. So I think that we need to do a little bit of experimentation here to figure out what's going on. So libraries and modules. FinTech, I completely agree with you. Without a doubt, yes. Node JavaScript developers, we got these package.json files that are like enormous. Okay, this one's not, but like let's look at this one over here. No, oops, same one. Okay, well here's, the project I'm working on right now has a, I don't know, non-zero number. But any production project, you're going to see like possibly dozens of different modules included on it. I think that the reason that you see that is twofold. And I've thought a tremendous amount about this. Why do we see so many libraries and modules? And it feels like we also see a lot of libraries and modules being used specifically on React projects. If you go and look at an Angular project, for example, or I have worked previously, I've got a tremendous amount of work experience with Backbone. And with Backbone, we had very, very few dependencies. Backbone almost famously only depended upon jQuery and underscore. So Backbone itself had 2 dependencies. That was it, and you were good to go. So why does it feel like now, all of a sudden, we have so many dependencies stacking up? Why do we have so many modules and libraries that we depend upon, specifically in React projects? So like I said, I think it's twofold. Number one, I think the first big reason is that with React, there's been this culture of writing very modular code, specifically around Webpack. Around Webpack, there is such an emphasis around plugins with Webpack. Everything is a plugin with Webpack. Even Webpack at its core is like a plugin loader, and a lot of the ability to process files at all or load files at all is like a plugin in of itself inside of Webpack. So when you look at Webpack, it's got this culture where every last thing that you can possibly do is a plugin. And you can take that type of culture over to the React world as well, where React very famously is like a view layer. And so as soon as you want to do any data fetching with React, well, now you have to install Axios, or what you can use fetch if you want to. But even if you use fetch, you're probably going to install a polyfill for that as well. And then with React, okay, you've got the view layer. For the data fetching, you got Axios or whatever else. For data management, you're going to pull in Redux. To bind React to Redux, you're going to pull in React Redux. And I think the reason you see all these very small modules is a very common belief in the community that small modular code is like a holy grail beyond all belief, and it's like just the best thing in the world. And so I think that when you look at these module authors, they really embody that, and they think to themselves like, yes, we want to write this like tiny little modular code that you can, like, it just does one thing and does that one thing really well. And so if you want to go and build a real project, inevitably you have to pull in dozens of these modules because each one does exactly one small tiny thing very well. I said there's two reasons. So that was reason one. The second reason I think you see a big dependency on libraries and modules is, what was the second reason? I'm totally blanking now. So we got all the people who depend upon these things. Did I really just forget that quickly? Well, the first reason I think is good enough. I think I kind of integrated the second reason into the first one. What I was going to say for the second one was that when you look at React specifically, React is just the view layer, and so to do anything else, you have to start pulling in these other dependencies as well. So the two kind of build on each other, I suppose. It's number one, the culture of we want to have small modules that do one thing, and then secondly, React specifically and like Webpack specifically as well, or excuse me, really just React specifically, cannot really stand on its own very well. And common practice is to pull in all these modules and dependencies and libraries to make it behave the way you expect. And you just don't see that with, say, Angular or Backbone or some other large frameworks where they have these dozens of dependencies. Like you can install Angular in a project and get kind of far. You can get pretty far with just Angular. Like it's an entire solution in itself, has batteries included. And you'll see that with a lot of older frameworks as well, like specifically Backbone, where Backbone has everything you need, more or less, to build a pretty complicated web application. That's just not true of React. So I think that a lot of this is a symptom of React specifically, and I don't know that we're going to continue down this path forever. But this is just my opinion. Yarn, yes, Yarn is terrific. Well, later versions of NPM now, like version 5, has started to kind of incorporate a lot of the improvements that Yarn brought in, which is great for us as well. So question here, I didn't get how the value is updated in Solidity. Is this something not explicit? So value right here is like the amount of money that I'm attempting to contribute to the contract. It's definitely not working right now. So something is like going wrong here. I did previously I think I actually have a test around this, and we could probably just go look at the test. Like, okay, here's the test file right here. Here's the instance of the contract, and I call contribute and pass in a value. Oh, it's from. I think it's from. I think that's what I forgot. Let's try that really quick. And from web3 accounts, web3.f.accounts. Let's try this out. I think that's where we're going wrong. FinTech, I think you don't see that in C# though, because, second reason. Yes, second reason. Now it came to me. Second reason, JavaScript has a very, very, very weak standard library. And I think that is not the case with C#. I know with several other languages that I work with very frequently, like Ruby, Elixir, and Go, they have extraordinarily strong standard libraries. And so you don't need to install these third-party modules to do very common things. A great example is what we were just talking about a second ago, Axios. JavaScript did get fetch, but like I said, you can't really assume that fetch is always available inside the browser. even if you're making use of fetch, you're probably going to be making use of a polyfill. And so I think that the weak standard library of JavaScript comes into play tremendously with that as well. All right, so anyways, back over to this. So we're calling contribute here. We are passing in our value. We're saying who it's from, but it still appears that we are not getting an update on the number of contributors or the amount pledged. In addition, we're not seeing MetaMask appear and saying like, hey, are you sure you want to like contribute this money to these people? So it really continues to appear that something is very much off. I want to try to create a new contract to see if something is off with MetaMask. As I've said several times throughout the last bit here, MetaMask is kind of a, okay, so MetaMask appears to be working, so we are able to submit the contract. Here's our new contract right here. We should now be able to contribute. Definitely not working. Let's try dumping the .then, and maybe this is a, I don't really want to call this a value, but whatever, we'll call it that for right now. Let's try throwing that on. Okay, invalid number of arguments. Okay, so that's definitely complaining here still about the callback function. So let's go back to the .then that we had before, like so. Esdras, so you had a message about how the value is updated in Solidity. So when we call contribute, we have to specify how much money we are attempting to send to this contract. I haven't really said anything about contracts in general on the stream, but contracts you can imagine as being like another person. Like essentially, you can think of a contract as being a person. So a contract can receive money. It can like do stuff with that money. When we want to call this method right here, this is a method that I defined inside of my contract. So I'm going to go over to my contract definition over right here. Nope, that's the build folder. Here's crowdfund. So here's my contract. This is the thing that we're trying to send money to. So if we scroll down a little bit, you'll notice that we've got the contribute function. So whenever we call contribute, there's a global variable available inside of Solidity called MSG, short for message. Message has two properties assigned to it, among others. One is value, the other is sender. Value is the amount of money that we are sending along with the, essentially this like invocation of this function. So this is the amount of money that we are trying to contribute. And then we've also got message.sender right here. That is the person who actually sent the message. So this would be message.sender is an address. In the browser, I am trying to call contribute as a particular user. So the address in this particular case would be this OX6273 blah, blah, blah. So essentially, when we're specifying value right here, we are saying like, here's how much money we are trying to send to the contract, and the contract is eventually going to read in that value and make sure that it's like, you know, above some minimum contribution. Minimum contribution right here is all in the context of like crowdfunding. So I don't want people to contribute to my crowdfund for amounts of like 1 penny. If you're going to contribute to my contract, I want you to give me some real money. So I'm trying to say like, hey, this is the minimum amount of money that you can send and still like be included in this contract. So that's the idea of that. Now, I've been stuck here for like the last 20 minutes. I've definitely been getting kind of caught aside here with the whole issue of MetaMask not really picking up on this contribute call right here. So there's definitely something like just super, super, super wrong with it. Again, I've got the tests over here, and the tests are super crystal clear. Grab the deployed instance of the crowdfund contract, call contribute, specify the value that we are trying to contribute and who that amount is coming from, and then we can, and that's like it. There's nothing else for us to do here. We call contribute, that's pretty much it. Things should just take care of itself from there. But when we are running this inside the browser, it appears that is like just decidedly not at all the case. It looks like something is very, very wrong when we start to run this inside the browser. So I can call contribute. It appears that the transaction like occurs because I get the console log here. This is a console log of the arguments, but nothing is actually happening. So I'm going to focus now on this for a moment and try to figure out what's going wrong. So I apologize if I do not really pay attention to chat or if I don't really explain what I'm doing here. Well, I'll explain this. So the first thing I really want to do is make sure that when I try to contribute money, an actual network request is being made, which would indicate that we actually are reaching out to the network and trying to transfer some money here. Definitely no request here, so something very wrong is happening either with MetaMask or with the truffle contract that we're working with. So kind of get the feeling that this is okay right here. Something else is really going wrong. And you know what I think it is? I think it's this line right here. I think that we're returning early. I bet you anything that's it. Yeah, okay. So let's focus now. We're going to put our debugger in here. And we're going to see what's going on. So I'll contribute 1. Oh, although we were getting that console log. So maybe that is not it. Let's just step through and see what happens. Okay, so it does work successfully. Like we get in here, so contribute. So here's like contributes there, not an issue. Let's look at our contract. Here's contribute. What could be going wrong here? So we're trying to call contribute, but it appears that somewhere along the way, like this request or trying to call contribute is just plain not being communicated over to MetaMask. Why would it not be getting communicated to MetaMask? You know, and I had another project. Let's look at this other project that I had really quickly and see if there's something like very discernibly different inside there. Let's try, look at that one really quickly and see. Oh, I've already got it open right here. Okay, so here's another project I was working on. This one was like lottery themed essentially. So you could like enter into the lottery and then a random winner would be picked and that random winner would win all the money. Hooray for them. So previously over here, you'll notice, so this is like, though I called the lottery a contest. So we're doing essentially the same thing as I'm doing back inside the crowdfunding. So I'm calling enter contest. The big difference here is that I had made this manager object right here. Manager was this like account manager thing. The purpose of this was to kind of like wrap up all the functionality of Ethereum outside of my React application. I thought it was a clever way of doing things. I don't know if it is, maybe it's not. So in this case, we have from, we have value, everything worked here, and this code looks pretty darn identical to what we're working on over here. So contract, let's split screen this. Okay, so we've got the instance. The instance is what this .state.contract is. And we call enter. In this case over here, the method was called enter to actually like enter into the lottery. Over here, it's called contribute, like no difference. Let's drop off the .call though and see what happens. We've got from, we've got value. Here's the address that it's from. Yep, that's the address it's from right there. And then we've got the value. It's basically the same thing. Over here, you'll notice that I'm making use of Web3 utils.2way. That's because this project was making use of Web3 version 1.0, whereas this is making use of version 0.2. Maybe that's the source. Maybe that's the source of our issue. I don't know. Maybe it is, maybe it isn't. Here's what I know that I want to do. I want to do it. Actually, you know what? We're going to do this the real way. So here's, in a very practical setting, this is what I would really do. So I would put a debugger statement right above that function call. And I'm going to try to contribute 1. And honestly, this is how I really go about things, is to walk through the code and get a sense of like what's really going on here. So I'm going to walk through as much as function call as I can really stomach. So here's the two-way call. Here's on submit. This is to get the account. That's fine. So now we're going to step into the contribute function call. So at this point, if I look at arguments, I should see an object that contains the amount of money we're trying to send and who we're sending the money from. So this is definitely the correct address. This is definitely the correct value. If I look at the amount of ether that I have, I've definitely got enough ether. So this should be 1 ether right here. I have 88 available to me. So at this point, everything looks okay. So let's continue walking through this and see what's going on. So I'm going to walk through. I'm not seeing anything here that's necessarily going to like cause my cause the function to return or anything like that. If it's only transaction params, okay, so I am working only with transaction params. That is working, or that is correct here. So tx params, I'm interpreting as being like these are parameters for the transaction that I'm attempting to create. So that looks good to me. I'm happy with that. And then we're going to return this thing right here. And then we're going to enter into, presumably enter into that. So we don't know what any of that stuff is. The transaction receipt. Here's the transaction. So I think that let's try walking into this thing. See what happens. Oh, you're kidding me. Seriously? This time it's going to work this time? All right. Okay, well, let's submit. Now so we presumably submitted the call to contribute. Let's check out our log over here. So here's the transaction that represents me trying to contribute to that thing. So that looks okay. So now we're inside of this like get transaction receipt, which presumably is where I'm going to get some receipt here. So here's a result with 11 right here. This is the transaction receipt. So here's like result right here. That should be my transaction, either my transaction receipt or reference to me, the sender. We can very easily check over here. So okay, so here's the transaction 676. Yeah, 676 right here. So when we debugged the transaction, everything worked fine. When we do not debug the transaction, things do not work. That is kind of, part of me wants to say that's really interesting, but really that's very concerning. So if we now refresh, we'll see that there are correctly one contributor and one ether has been pledged. So I just commented out the debugger statement right here. Let's see what happens now. Oh, you kidding me? Really? So now it's going to work? I am extremely thoroughly confused. I made no change to this thing whatsoever, but now it's going to decide to just work. Well, I guess I should just be happy that it's working. All right, so it works. Hooray for us. So I'm now able to contribute to the campaign. That's good. So we can print out our number of contributors and how much money has been contributed. So obviously we need to do a little bit of work on formatting here to give a better sense of how money has been pledged to the campaign. The other thing that would be really nice is to make sure that after some money gets contributed, it'd be really nice to like update this thing or show the user something that says like, hey, we're processing your contribution. So I think that what we want to do is have the ability to set some like additional loading flag or something like that. So I think that we'll do that right now. The first thing we'll do is move this all the logic inside of component did mount to some other helper method so that we can call this repeatedly so we can refresh stuff like the balance of the contract, the number of people who have contributed and all that kind of good stuff. So let's move this to call it like load contract is fine. So load contract, we'll make that an async method. Component did mount, we'll now call that. So this dot load contract, like so. So now everything should still work the way it was before. And everything looks good. But now we can make sure that whenever we add on this thing right here, or whenever we call on submit, we'll make sure that we also do a follow-up and call load contract. The other thing, like I just said, I would like to make sure that I also like give my user some notification that their transaction is processing. So I think I'll mark this as async. We will await this. Maybe right before we'll say something that like this dot set state like loading true. I know that'll work. Now, one thing that's kind of interesting here about Ethereum is when we call this method, this makes the transaction, or it's like kicks off the transaction. But the transaction doesn't actually get like finalized potentially for several minutes. Yeah, I think that's probably, you know what, we're just going to ignore that for now. Essentially, what I was trying to say was that in a local environment, you know, where I am right now, all these transactions, when they're created, get instantly fulfilled and recorded and whatever else you want to say. Essentially, the transactions occur instantly. But in a real production environment with Ethereum, there's some real delay between starting up the transaction and actually seeing it like conclude or finish up. So normally we'd want to handle that in some fashion, but in this case, I think for right now we'll just say like everything's okay. So after we await this contribution, I think that we will want to call load contract again to load up, to refresh the display, excuse me. So this dot load contract. So now, okay, so I should be able to contribute 1 coin. I'll submit, and now we reload the contract and we're up to 4. Okay, so that works for me. Obviously, this could use a lot of visual decoration, but that's something that I will come back to far in the future, not right now. Now the next thing I would like to do is fix up the pledge thing. This is in Way right now, and it would be a lot more usable if it was displayed as Ether. So let's do a quick conversion here. So we'll do web3 dot, and we just did this 2 seconds ago. Blah, blah, blah. Two-way from Way is what we want. So web3 dot from Way, and I want to convert this to Ether. And so I'll put little ethers right after so people know what units they're looking at. Okay, so now it's very clear 4 people have donated and 4 ethers have been pledged. Here's the owner address. Now there's still, I had mentioned there's a lot of information available on the contract itself, and that is true. So let's take a look back at the contract and see what other information we can stuff on here. So some of the other stuff, there's like that request field, which is request from the owner to actually spend some money. But I think what might be a little bit more relevant, I thought I had a description on here. Apparently I don't. I think I'm going to add on a description. I kind of want to add on a description. I kind of want to also add on a record of requests that have been made. Trying to think of the best way to handle this. One thing that's really, when you start working with Ethereum and Solidity, one thing you recognize really quickly is that it's extremely important to consider your data structure or how data like exists inside of your contract. I mentioned a little bit ago how mapping right here, so mapping is like a map or a hash map or essentially the same thing as a JavaScript object or a dictionary. And we can't iterate through the mappings, like we can't iterate through all the keys. So if I wanted to figure out like what actual values are stored inside this mapping, I would separately have to store an array of like uint32 of something like request IDs or something like that. And then every time I add a new mapping or a new record to the mapping, I should say, I would also push that ID into request IDs. And that is literally the only way that I could then at some point like pull data out of here. Otherwise, I would have to somehow memorize outside the contract all the different IDs or all the different keys I had added to this mapping. So I think we're probably going to have to do something like this request IDs right here. I had previously been thinking that the request IDs would be stored on the separate server, so completely like outside of this crowdfunded app or the crowdfund contract. But now I'm thinking that's probably not a good idea, and so I'll probably want to store the request IDs in the contract itself. So I think that we'll probably do that. The real question is what we want to call this variable here. We've already got something called requests. Request IDs, yeah, that's reasonable, I guess. It definitely doesn't need to be a uint32. I think we can size this down a little bit. 16 should be good enough. Okay, so now whenever we create a new request, create request right here. So we allow the caller, or the person who is trying to create the request, to specify their ID. And we specify it as a uint32. So actually, let's stay consistent here. So up inside this array up here, this needs to be an array of 32. So request IDs. So we're going to take requests. There we go. That looks good. Request IDs dot push ID like so. Okay. So now whenever we create a new request, yep, that looks good. The other thing that we need to be aware of is the React app side does not currently allow owners to create new requests. Maybe we should take care of that first. Yeah, let's take care of that first. So we're going to come back and make use of this request ID stuff in just a little bit, but first I really want to make sure that my owners have the ability to create a request. So I'm going to add in a new route to the React side of the application. Contracts, address, requests, new. That'll work. And the component that we want to show here, we're going to make a new one, request new. All right, making the React components is the easy part. I can do this all day. This is the easy part. It's the Ethereum stuff that takes just forever. Class request new. So what do we want to render here exactly? So we want to allow the user to create a new request. So we definitely need to have a form. Let me show the form. So I think that we're going to need a few like form fields. So we're going to stick each of them into their own div. Each one's going to have a label. It's going to have an input. The input will have some onChange property. Let's see what all. I think we have enough fields here that we're going to want to write this a little bit more cleverly than trying to like write out. So we need description, amount, recipient. I think that's it. Description, amount, recipient. Okay, we can just do that by hand. We won't do anything too clever here. State, description, amount, recipient. Set state, and this is going to be, let's see, value. Start off with the description. Excuse me, not set state. Getting ahead of myself again. Description. Description will come from target value. And this will be description, like so. Okay, so now we're going to paste this 3 times over on 2. Recipient address. Recipient and value. We could probably do some destructuring here to shorten up value. Value in this case is the amount of ether that we want to assign. So I don't think destructuring makes too much sense here, so we won't do that. Okay, so we've got our form now. This is going to, let's see, what do we have to do here? So let's first show the form, make sure we have that much working. Render method should have a return statement. Yes, it should. I don't disagree with that, not in the slightest. Okay. Okay, so now we need to add in, we need to go to this request new, and actually let's do somewhere inside of the contract show, we should probably give the user the ability to see a button to create a new request. If you've joined recently, I've repeated this like 3 times here, but the context of this application is we're making like a crowdfunding contract, but the money that is donated to the crowdfunding campaign can't be freely spent. The owner has to make like a request to spend money, and then that request has to be approved. And so I really want to make sure that the owner has the ability to click a button on this contract detail screen right here to make a new request to send some money to some new recipient. So I'm just going to place an arbitrary link on here right now. Let's see, this is going to be, oh boy, this is going to be a long route. So contracts, this dot props dot Is it param? No, we got it right here. Address on contract. Let's pull this out. And we'll do some structuring. Address. Address. Request new. Cool. Okay, so now we should be able to link very shortly. Link React router DOM. Okay. So now we should see our nice button that is nowhere to be found. Why don't you want to show up? Oh, yeah. Sorry guys, first time streaming, so making some small mistakes here as I focus on talking so much. This should have some content inside of the link. Create request, of course. All right, so now I can create a new request. It takes me over here. That's going to be my request new. Let's put some better text on it than that. Create request. So that's going to be the button that we're going to show. The form doesn't really have any context right now, so maybe I'll just add on a quick note that describes what the form is for. We'll put on a H3, I suppose. And let's kind of give the user a context clue of what this is all about. So create a spending request. I think that's probably reasonably clear. So create a spending request. Okay, so we got the description, the recipient address, and the value. You know, I think I'm missing. You are also supposed to specify the ID when you create a request. Create request, yeah. You need to specify the ID on this thing as well. So unfortunately, I do need another form field here. That request is also supposed to be an integer. Oh, now I'm remembering why I didn't want to. Yeah. Let's say ID of request. And so this ID here is really supposed to be an integer. I think we'll do a parse int on this thing, and we'll default it as like 0. I'm not really enforcing. We're not going to have a great way of enforcing uniqueness on IDs. That's going to be something we're going to kind of like gloss over in the context of this app. I've got an idea or two of how we might approach that in the future, but for right now, I think it's totally fine. All right, so now a user can add in the ID, the description, recipient address, and the value. Great. Okay, so now once someone adds in all that stuff and attempts to submit the form, we're going to want to make sure that we do the same thing as we did just back on contract show when we tried to contribute to someone's account. So essentially, we're going to want to call, oh, we are missing one thing. We need to first get a reference to the account. Let's not forget that. So we essentially need to do all this stuff over again. That is unfortunate, but we will do it. So async. This is definitely logic that could be extracted out to some helper class or module or anything basically, because doing all this stuff repeatedly, really not good. All right, so we are going to take our address off of the URL. We are going to try to fetch our contract definition. We're going to create a new contract class out of that. We're going to set the provider. We're then going to retrieve the instance based on the address, which is coming from the URL. Okay, so this looks good right here. So now we've got the instance, and we definitely will refactor that to hide that code away and make sure we're not repeating all the same stuff again. So now we are going to take just instance .contract.create request, like so. Okay, now this is looking pretty good. So this time, when we create a request, there's no value being assigned to it, but we do need to specify where the request is coming from. So I'm going to specifically leave on there at that account 0. That looks good. I think we can do a little bit of reformatting here in just a second, but we're going to have a lot of arguments here. Actually, you know what, let's just kind of condense this down right now. This is going to have several arguments assigned to it, though. So one thing that's really interesting, well, actually, it's not that interesting, I suppose. If we look at our crowdfund contract, when we create a new request, we've got several different arguments coming in here. So we got an ID, description, amount, recipient. So we need to just make sure we call create request with that correct order of arguments. So the first one will be this. And you know what? Let's get clever here, and we'll do a little bit of destructuring. So const ID, description, amount, recipient, like so. ID, description, amount, recipient. Okay, I think that looks good to me. So we're going to create the request. Then after that is done, we need to redirect back over probably to the contracts like detail page. And then in a little bit, we'll make sure that that page also shows the list of all the different requests that have been made. So the redirect will be the easy part. I'm just going to do a quick copy paste here. So that's React Router, being React Router, contracts at address. Show me that page. And we've got some typos here. So our import statements, of course. Not that one. Just want to see my browser. Did I miss anything? Axios and Web3, that's it. Okay, so Axios and Web3, I think we're good. Don't need to double up on contract. All right, how are we doing? Okay, so ID for the request, make that 1. I need, oh, and you know what? I really need to parse int on that thing. Like so. Okay. Description, I need money to make the product. Recipient address. Now this one's a bit tougher to like source the address. Here, over here is my Ethereum local node that I'm running for a test environment. I'm currently pretending that I'm logged in as this person right here. So I'm going to pretend that I want to create a new request to send some amount of money to this address right here. And again, in the context of this crowdfunding app, we're going to pretend that this expenditure of money is going to this person because they're going to do some vital service for me to help me actually like produce my product. So I'm going to put the recipient address in there, and the value that I want to send. Oh, this really should have been another instance where we make use of ether as opposed to just value. So let's fix that up as well really quickly. So value as ether, just to make sure it's really clear how much money is being sent. And then right here we'll do web3 dot two-way amount from ether. Looks good. Actually, the code looks nasty, but it does what we want. This all needs to get refactored into something a lot better than what it looks like right now. I feel like this is a great example where a higher order component will probably be used. So I've got this repetitive logic right here and the same exact thing over here inside of contract show. In both cases, they really need to get access to the current contract that the user is trying to view. Easy way to kind of, I don't know, deduplicate this code would be to move it into higher order component. So we'll probably, I don't know, maybe, I don't know, we'll figure that out. All right, so let's refresh this again. So I want to do ID request of 1. I need money to pay for stuff. There's my recipient address, and then I want to spend 1. Oh, and it looks like we got an error. Okay, so I probably didn't hook something up all the way inside of request new. Probably a value property. State.value, target.value. This looks okay to me. What's going on? Which one did it throw an error on? The recipient, I think. Yeah, I made a typo somewhere inside of one of these. Okay, recipient, value. Oh, amount. This is amount. Although I'm not sure that would actually cause the error that we just saw. So amount, yeah, amount, definitely not value. So let's say dot amount. Yeah, I don't think that's going to will cause the error that we just, maybe it will. We'll see in just a second. So let's put in value of ether of 1. Yeah, no, come on, you're kidding me. Let's triple check, make sure that's actually the source of the error. Okay, let everything load. We're good. Put in the address, looks good. Put in description, that's good. Value is ether 1. Okay, so something's definitely wrong there. So what's going on? On change, I mean, I copy and paste this thing. There's no reason this one should be going wrong, but not the others. Oh, I'm using, no, e.target.amount, amount value. That's why we don't use the word value, like as state. That's why we don't use it, because otherwise weird things start to happen. Okay. All right, so we're better off now. I need money for things. Here's the address, values ether, create request. All right, now we get this fantastic error, and let's see, request new, let's find that submit. Okay, so here's submit. So does not support synchronous methods. I can't even possibly imagine why this is being called right now, because we just did the same exact thing back over inside of contracts.show. Here it is inside of contracts.show right here. Oh my, I can't even possibly imagine why this is coming up. Let's, the documentation says the call method is advised. Let's try that out. I suspect that's probably it. I need money for things. You kidding me? So why in the world is this going to work in one place but not the other? So over here, here's RxJS instead of await. Chris, this app I'm working on is in the context of a Ethereum course that I'm putting together. And Ethereum, I would have loved to really do Ethereum by itself and not have to worry about like React or anything like that. So even using React on this project right here is kind of too much. I think that there's going to be a lot of people who want to learn about Ethereum who don't know about React at all. And so while using RxJS would be really cool here, I think that the issue is that it would just add on like one more dependency that people would have to know about, or one more like qualifier to be able to take the course and really understand what's going on. So, that would be neat, but I'm trying to like kind of constrain the number of topics we have to discuss. Anyways, so back to this thing. So we saw an error just a moment ago complaining about MetaMask doesn't support synchronous methods. Presumably that's because we are not passing in a callback here. I think that this is really coming from the fact that in this case we called a method on the contract with only a params object. And in this case, we called a method on the contract with arguments in addition to the params object here. I really think that's what's going on, which is extraordinarily unfortunate. I think this is probably a bug within Web3 is kind of what I'm thinking here. We can test this out really easily. So we can add in our callback function, which will look a little something like this. And I'll leave it looking really nasty for right now. That's totally fine. So now we don't need the await anymore because we've got a callback function in there. So let's try this out and see how we're doing. Description, I need money for things. Recipient address. Oop. That's not my recipient address. Let's see, I need my second account. Here it is right here. 1 ether create. Oh my goodness, it actually worked. All right, well, that's not bad. Okay, so we now have the ability to create requests. At this point, man, I am starving. I have not had lunch, and it is 2:40 p.m. So I think I'm going to take a quick pause here and grab some quick snack. I'm not like a fancy streamer. I don't have any like neat thing to say like, oh, I'll be right back. So I'm just going to put a text note on here that says like, lunch break. I think that'll work just fine. So yeah, we're going to go for lunch break. All right, so lunch break, be back in like 10:15. See you guys in a minute. All right, I'm back, and we still got 3 people here. Awesome. Well, hopefully we can keep things interesting. Let's see where we're at right now. All right, so let's take this out. Shrink our font size down to a reasonable level. Very good. Okay. All right, so let's see. Last thing we've been working on was we had got the contract detail page, or excuse me, crowdfund detail page working. I guess contract. We had the ability to create requests. We don't have the ability to show them. One of the things that we had to do to show them was make sure that we had the ability to actually like map or essentially get a list of all the different requests that we had made. If the people who are still here recall, when we were talking about our crowdfund contract earlier, we were talking about how we had this mapping right here. And the mapping stored all the different requests that had been made for a particular crowdfunding campaign. This mapping right here stores everything by a key of a uint32, so essentially a number. However, when we're working with Solidity, which is what this Ethereum contract is written in, we can't really iterate over all of the key value pairs inside of a mapping. Remember, a mapping is like a dictionary or a JavaScript object or a hash table or whatever you want to call it. So really, we need the ability to store a list of all the different requests in addition to this mapping. So we can actually go from a request ID to the request that we want to pull out. And that was the purpose behind this request IDs property right here. So request IDs was going to store all the different IDs that are stored within the mapping. Now the very obvious thing to question here is, well, why are we storing both an array of request IDs and the mapping? Why don't we just store like one or the other? And the reason for that is that generally it's easier to, if you really think about our situation here, where what we really care about is having the ability to display a singular request on the screen at a time, it's really ideal for us to be able to pull out one particular request. The other thing that is kind of interesting about this is when you start working with arrays and Solidity, nesting if you look at, so here's a request, or the mapping for a request. So we map a number to a particular request, and here's the definition of what a request is right here. And you'll notice that the request itself has a mapping of its own. And I'm not 100% sure on this just yet, but my intuition is that storing a, how do we get this just right? Storing a mapping, storing a mapping within a mapping is okay, whereas storing a mapping within an array is not quite as okay. And I'm not 100% sure on that just yet, but that's kind of my intuition right now. So kind of want to make sure that we just stick around with having 2 mappings here nested inside of each other. Anyways, speaking of which, I think that the relationship between these 2 things is unclear, so I'm going to kind of move that. So now it's really clear we have requests, we have request IDs, and requests. Although now I'm really thinking and wondering maybe we should just have an array of requests. But I know there was a reason that I went with the mapping right here. I just can't quite recall what it was. What was it? Because even when we start thinking about how we have to like render out the list of requests inside the app, we're going to want to be able to iterate through all the requests anyways. Oh, I could have sworn there was a reason for this. You know, what was it? I think a lot of it was because we didn't really have a good idea of how many requests there ever might be. And in order to pull out a particular request, we would have had to iterate through the array of requests if we were dealing with an array of requests. And any type of computation inside of an Ethereum contract is extremely expensive. I think that was the idea behind it. So what the heck, we'll just stick with that. I think that's good enough. So, all right, so request IDs. Let's see, we've got request IDs, create request. So that should be good to go. We are gonna have to restart up or recompile our contract. So let's delete the build. We will kill the Solidity, or the truffle dev server, start it back up, and then we have to very unfortunately also reinstall MetaMask. Hey, by the way, is everyone still listening? Say something in chat. Otherwise, I'm really just talking to myself here. I should really send out like a tweet for this stream, but I wanted to see how it just went this first day before I made all this really publicly accessible. I feel like it turned out pretty well. All right, so we got MetaMask. We need to get our mnemonic. Accept. Accept. Import. And then we'll set up our custom network. All right, so there's our account. We're back on the contracts list. We should have no contracts. Should we? No, we shouldn't have any. Why would we have any contracts? Shut down everything. Maybe it's just the accounts that get reset. No, that can't be right. Let's kill it all. All right, let's see what we got here. What is this? This is create React app, node. We got nothing going on over here. All right, let's restart the server. Oh, looks like we got 2 running. There we go. Okay, I think that we're probably okay. This is not really going, but that's okay. So let's refresh. Why do we keep on seeing the contracts list appearing on here? I really don't expect that much. Let's also restart Chrome really quick because it's getting awfully laggy. Chrome. Okay, and restore. Nope. Not YouTube dashboard. Okay, whatever. We're dealing with the same contracts. Really expect those to disappear. We'll start it back up. So let's do minimum campaign. Or campaign with minimum contribution of 500. All right, I think everyone is out. 0 watching, I believe. So I would really like to close everything down. Yeah, let's kill for today. All right, if anyone's still listening, I'm peacing out. I'll catch you guys later.